Hello Sudoku fans, thank you for joining me for another Sudoku solve. Today we are going to be doing a hard Thermo Sudoku. For those that aren't familiar, Thermo is a fairly popular variant of Sudoku which introduces these thermometers. So if you're not aware of the rules, I shall go over them now. As per all normal standard Sudokus, the digits 1 to 9 must appear exactly once in each row, column, and 3x3 box of the grid. Additionally, these thermos, starting from the bulb end and going upwards, the numbers contained within it must ascend. As an example, if this is a 4 in this digit, then this one would only be able to be a 1, 2, or 3. It has to be lower, and then going the other way could only be a 5 or higher. So let's get solving. And with the Thermo Sudokus, it's always worth looking at the large thermos first because they are very restricted. Now, because there are seven digits within this thermo, basically gives us, and we need to put in the one, we only have the digits 1 to 9 to work with. It basically gives us a tolerance of 2, where an additional 2 numbers can go in each box. So what do I mean by that? Now let's start by looking at the lowest numbers. Obviously the lowest number for this is 1. Working our way up, these are the lowest numbers that can go in each section of the grid. And then working down from the highest numbers, we can look at the highest numbers that can go in each section of this thermo. So the highest number of this is obviously 9. The highest number for this is actually a 7 because there's already an 8 in here. This is a 7. The highest number of this is a 7, so the highest number for this can be a 6. The highest number for this can be a 5. The highest number for this can be a 4, a 3, and a 2. There's another 7-digit thermo here, so it's similarly restricted, but the first digit can actually be a 1. So that can only be a 2 or 3. That's not right. 5, 6, 7, 8, 9. So because of that restriction, there's actually only 2 digits that can go in each of those spaces. Also worth looking at these middle thermos. This is obviously 1. If a 1 is in a thermo, it can only go in the bulb. Anything else would require a digit lower than 1 to be closer to the bulb. Because of that, a 1 cannot go in any of these spaces and can't go here because of that one over here. So that is the only space in the middle box that can be a 1. That means one of these is a 1. We have a lot of options for that. Can we see? So also there's a lot of not a lot of options, I don't think, for what can go in these thermos. This one can't be a 1. So the smallest this can be is a 2. Smallest this one could be is a 3, but this number cannot actually be a 3 either. If this number were a 3, then both of these would have to be 2s. This one because 2 is the only digit left, and this one because 2 is the only digit that's lower than a 3. So this cannot be a 3, it cannot be a 4, so the lowest this can be is a 5. And we get 6, and we get 7. The highest this can be, actually this cannot be a 7, but I'll come back to that. The highest this can be is a 9. This can be an 8, and it can't be a 7. The highest this can be is a 6. And the highest this can be is a 5. It cannot be a 3. Okay, so why can't this be a 7? Well, it's interesting because it's actually the endpoint of 2 thermos, which take up so much space in this box. If this is a 7, we still have to fit 8 and 9 into this box. But obviously, apart from this space, all the other digits that are remaining are lower than this one. So therefore, it cannot be a 7 because then we do not have room to put the 8 and 9 in this middle box. So if this is an 8, this has to be a 9. So one of these is a 9 for sure. The 8's a little bit more free. The 8 could go in, well, can't go there, but the 8 could go in any of those free spaces. Now, 1s and 9s are always useful to look at in thermos, but this one's interesting as well. It's actually can't be a 1 or a 2, so the lowest this can be is a 3. That's going to put a lot of restrictions in here, I think. So this can't be a 3, it can't be a 4. Lowest this can be is a 5, and then 6. And the highest this can be is a 7. The highest this can be is a 6. And the highest this can be is a 5. Now, 2 is very restricted in this box, as is 3, actually. It's very interesting. 2 and 3 have to be in these 2 spaces. There's nowhere else either the 2 or the 3 can be. So that can't be an 8 or 9 because it has to be a 2 or a 3, which means our 9 has to go here and our 8 has to go here. Also, interestingly, we have a 5-6 pair in this box. So one of these is a 5, one of these is a 6. We don't know which order, but that's fine. It means that this cannot be a 6. It's a 7. Now we've done a lot of work in that box. We've also got a 2-3 pair in this row, which interestingly means that that cannot be a 2. Let's go and see, maybe we've got a couple of other smaller thermos to look at. This might be worth taking a look at now. And this could be a 9. But this couldn't be an 8. The highest this can be is a 7, the highest this can be is a 6, 5. The highest this can be is a 3. And the lowest this can be is a 1, 2, none of these can be 4, 3. This can't be a 4 either, so the lowest this could be is a 5. The lowest this can be is a 6. And it can't be an 8. So not super restricted, but because of its nature of being a slightly shorter one, it's got a lot more room for a lot more margin for error. This 8, this can't be an 8. Where does the 2 need to go? 2 can go here or here. Okay. I don't think these digits can be particularly high. Bearing in mind that there's an 8, 9 here, there has to be an 8, 9 here, There can't be a 7. There has to be a 6 along here. And there has to be a 4 or a 5 along here. Oh, hold on a second. I'll come back to that, but there's a 5 seeing this square. So that has to be a 4. That gives us a lot going down our Thermo. That's a 3 and that's a 2. Now, that's very interesting. So this cannot be a 4 or a 5. Now this is a 4 or 5, but we need another 4 or 5 in this row. It has to go in one of these spaces. If this was a 5, this would have to be a 4, 3, 2, 1 to actually fit in this Thermo. But we cannot have a 4 and a 5 there because of this. So this cannot be the 4 or the 5. Which means, and this cannot be the 4 or 5. So this has to be a 4 or 5. And then these ones are made up of 6, 8, 9. So obviously the 6 has to go in one of these two, and then whichever one's not here also has to go in one of these spaces. That can't be the 8 though. Makes this one a little bit more restricted as predicted. So that's a 3 or a 4, that's a 3 or a 2, and that's a 2 or a 1. Interesting 3-4 pair in this row. Come in handy down the line a little bit. Let's go see. One of those is an 8. Yeah, actually we've got the 8 in box 1. 8 cannot go in any of those, so that's an 8. And that puts the 8 over here. That means this is a 7. And then we can work all the way down the Thermo. And then that one has to be a 3 now. So sometimes these Thermos really cascade. Once you've found one digit, it can either go upwards or downwards and have like almost like kind of a domino effect where all the other numbers fall over. It is quite fun when that happens. Right. One of those is a 1. Are we seeing anything else interesting? 5 in one of those. Seven and 9. Not very useful. Hold on a second. This cannot. Hello. This cannot be a 1, 2, or a 3. Can't be 4, 5, 6. Can't be 7. Can't be 8. So it's a 9. So now the 7. The 7 can go here or here, and then whatever's not used here, the 1, 2, or 3 can also go. Now that one can't be a 3. So this cannot be a 3. Yeah, that sees that. There we go. So that's a 4, and then that cascades upwards. We know where the 5 is in box 6. Can't be in this column. So that's a 4. It also can't be in this row because of the 5, 6 double there, the 5, 6 pair. So that has to be a 5. And then that cascades down the Thermo till we get to the 1. So put the 1 there. Where does the 9 go in this row? It has to go here. The 5 has to go here. The 5 has to go here because of that column and that row. That has to be a 3 because we've got the 5 in there already. And that means the 3 has to go here. And that brings the 3 down here. And we've nearly done all the 3s. There we go. There's all the 3s. The 2 and the 4 go in here now. 2 goes in one of those. Here we go. I'm going to get all the 2s now, I think. 2s can't go in those spaces. So that's the 2. Oh no. Interesting. Interesting. We've got a 2, a double pair of 2s there. They see each other, so that means wherever the other 2 is, we must know about it. And yeah, we do. The 2 goes here. And that means that is 6. The last one in that row. That gives us our 5s and 6 down here. Our 5s can go here and here. So we only need 2 4s. Where do they go? Yeah. 4s can't go in those 2. And this box. 4 goes there. And you need 2 more 5. Oh no, we know about the 5s. And we know about the last 2 2s. 1s. 1 has to go here or here, which means that's a 1. And that's a 1. That's a 1. That's a 1, and that's a 1. It circles around. That gives us the 5 having to go here and here, which gives us the 7 in this box. Here's a 7 in that box. Goes there. What have we got left in this box? In box number 1, we need a 6 and a 9 in there. These 2 can be a 6, 7 or 9. This can also be a 6, 7 or 9. Oh. 6, 7 or 9. So what does this need to be? A 2 and a 8. This is a 2 or an 8. We know where the 8 goes because of this. That gives us our last 2 2s. 8 in this box has to go there now. 2 more 8s left. And there. the 9 in this box has to go here. This can't be a 9, so this has to be a 9. This has to be a 6. This is a 9. Turn off pencil marks. 6, 9, 6. That can be an 8. That's a 9. That's a 7. That's a 6. That's a 7. That's a 7. Last 7 goes here. This is a 6 prime pair. That's the 6. That's the 9. That's the 9. That gives us our last 2 8s and our last 2 6s. And there you have it. Thanks for joining me today. Tune in again next week for another solve.